All right, good evening. This is the 7 o'clock online office hours for my face-to-face statistical analysis course. Let me double check my stuff here. All right, good evening. This is the 7 o'clock. Might get a little bit of feedback. I am just checking to make sure everything's okay, and it looks fine. I always do a quick check just on my phone, so it doesn't have to be on my computer. I am streaming from an older iMac. I'm using Restream tonight. I think I may go back from Ecamm to Restream. I think I've finally got it finagled out. Both are about the same price, but I don't need both of them. And this one's very easy to use, and the mic and some of the other stuff sounds better in my opinion, but maybe I haven't tweaked the other, and maybe I've got an older Mac so it doesn't run as well. But anyway, what I'm going to be talking about tonight is continuous distribution. So I'm going to do a little bit, and basically I'm just going to do some guided practice tonight. No lesson through this. There'll be some discussion within the context of the problems. But I'm just going to go through a few of the problems, and tonight when I get done I will load this in the Moodle. I did not load Tuesdays. I did not load this one. However, they're out there. As a matter of fact, I already see a discrepancy with this one. It was pointed out the other night that I had June 7th instead of July 6th for Tuesday nights, and tonight I changed a little bit of it, but I did not change the date, so I have to go back there and do that before I make a final post on this. I'll change it in YouTube. And I'm also streaming on Twitch tonight, so I'm trying to stream back to my Twitch site, see if I can reach more folks. Let me bring the chat up real quick. And there's nobody on right this second, so I'm going to actually try to bring the music in the background back up. Wasn't working real well earlier. It's working now, and let me do a quick check to make sure it's not overwhelming. I'm gonna I'm trying to cut it back. I'm trying to cut it back. I got a whole lot of stuff going on the stream right now. No feedback in the mic as well. I got a whole lot of stuff going on the stream right now. No feedback in the mic as well. I got a whole lot of stuff going on the stream right now. I got it. Okay, I think I got it about right now, so we'll see. I think that's about right, so I'll keep finagling with that. Not a big deal. So, continuous distribution. So, as always, I've got my streamer, not always, but as of here lately, what I've gone to doing is just sharing one screen because it's less resources. And then I do have Adobe up, which is a little bit of a resource, so I can bring my normal distribution, standard normal distribution table. I'm going to have my GoodNotes here that I'm going to work through, which is working out fantastic. I had this brainstorm not too long ago that I would use this instead of Doceri, since Doceri is no longer supported and will soon at some point be gone. And then I scroll over here and I've got my TI-84. So there it is, my online version for the emulator for the TI-84. So with that said, let's get started. And let's talk about the normal distribution. So just like talked about in class, and we talked about the normal for quite a while because we were working with empirical rule and z-scores back when we were working measures of position earlier in the summer semester. So the mean, the median, the mode are all equal. They're all right there in the middle. So your mean, median, and mode are going to be right there. You see the symbol for mean there. The normal curve is bell-shaped and symmetric. So if you cut it there at the mean, folded it over, it would always fold over on itself, no matter whether it's flatter, taller, cut it in the middle, it's symmetric about that middle, and you could fold it over onto itself. Total area underneath is 1. The normal curve approaches, it's asymptotic. It approaches but never touches the horizontal, and it goes out to negative infinity here and infinity here. So it just goes on forever and ever. But remember last night in class I was talking about negative 3.49 and 3.49. In all honesty, between those two points on either side of the mean is really 100% of the curve. Anywhere else you go out there, you're gonna get some area under the curve, but it's just minuscule what it is. So, okay, and we didn't talk about inflection points because I didn't want to go down that road in summer. But at where it starts changing the curvature is at that first standard deviation right here. So you've got inflection points at those points on the curve. So nothing that we were going to study in depth this summer. Again, truncated 10 weeks. Wasn't going to go down that road for us. Okay, so let's talk about a standard normal, and let's go back to what I was doing last night in class, and I'll erase this standard normal off at the top that I had labeled that. And let's talk about an example. So let's say that we have data. We have some curve, or we have some set of data that is normally distributed, and it has a mean of, let's say, 53 and a standard deviation of 4.1. Okay, well, the mean is going to fall right here in the middle at 53, and then if I go 53 plus 4.1, not a hard thing to do. 57.1 would be one standard deviation that way. 53 subtract 4.1, so I can stay exact here. 48.9 on the other side. And we could continue doing that so that we have the main, what I would call lattice points here, the 0, 1, 2, 3 on either side of that mean of the z-scores. Now, this is a continuous curve. In other words, we're going to take into account all of the numbers along that horizontal. So when you look along the horizontal, we're going to take all of those numbers on the horizontal from negative infinity to infinity into consideration, dependent on the problem that we're looking at. I'm going to throw a few probabilities up here, and I'm going to work through just like we did last night. We had this conversation and more last night in class before we took the test. So let's do this. Let's say that these are test scores. Let's just stay with the example I had last night. Let's say that this mean is the mean test score for test 2 for my given test 2 over the last 23 years, let's say. So what is the probability that a single student would get less than a 54? Okay, so if this, go back to blue, if this middle was 53 and we went out to 57.1 there, so in other words, that's the 0th, at the mean, you are no standard deviations away from the mean, so you're at the 0th point right in the center. If you go out one standard deviation, we are at 57.1 as far as the data goes. What we need to know is at 54. So 54 is right about there. So what's the probability that a given student gets a score of 54? Well, we need to find the area, in this case, to the left, because we're looking less than. So I went ahead and drew a sketch. I labeled half of it there. And bring the chat up. Remember, if you're in my class and you come in, just let me know you're here. As of right now, got a couple of folks on, but not sure if they're from class. But just let me know if you're from class. So we are looking at the probability that x is less than 54. We could go to our table. We have a standard normal table that we've been working with in class, right? But this table is built around z-scores. If you look to the left there, if you go out, well, if you look at the top, I'm sorry, table values represent the area to the left of the z-score. This helps us. We can use this table, so we just need to find out what the area is to the left of our value and our value was 54. Well, there's no 54 in here because this is for a standard normal distribution. And what I've got here is just, at this point, is just a normal distribution. So what I've got to do, and that's not very visible. Not sure that's any better, but what I need to do is find what the z-score is at 54. So I need to find the equivalent. Instead of looking at the probability that x is less than 54, which is what our ultimate goal is, we're going to work with it with z-score. So probability that the z-score is less than some z-score that represents 54. So in other words, what is the z-score at 54? Well, so I need to find the z-score at 54. Well, that's not too hard. That's not too hard to do. In order to find z-scores, if you remember, we work with this form. We derived this in class. X minus mu divided by sigma. So in other words, the x value that we're looking at, which is 54, subtract the mean, which was 53. We were given the mean. Remember, the mean is right there. We were given that at the beginning. I arbitrarily came up with that number. So 54 subtract 53 divided by sigma, which is 4.1. Okay, well 54 minus 53, that's just 1. So I got 1 divided by 4.1, 2439. So the z-score at this point is 0.2439. Okay, 0.2439. So what is the area if I go back to here? 0.2439. So I'm going to have to scroll on here. First of all, I got to switch sides. I got to get to the positive side. And I'm looking for, whoops. There's 0.2 right there. So 0.2, and I need 0.2439. We don't go that far out on the table, but what's 0.24? 0.24 is right here. So if it was 0.2439, it's going to extend out a little bit further, but we're just going to take it out to 0.24. So I'm going to go back in here, and just for the nature of this example, I'm just going to truncate that back by dropping it off. So my area is 0.59483. So the area here is 0.59483. So the probability that an individual, student will get less than a 54 is the same thing as saying the probability that a given student will have a z-score based on their score on the test less than 0.24. And there it is. So they got about a 60% chance, right at a 60% chance of getting a score less than 54. On the flip side, remember we were flipping it last night because there's different ways. Oh my goodness. I'm sorry. I forgot that you weren't looking at it. So let me just backtrack 1 second. So we were looking at the probability that some individual student scored less than 54 on the exam. We put it in terms of z-scores because that's what we work with the standard normal. We don't have a chart for every single instance for all those real values along the horizontal. So we rewrite it as the probability that one individual student has a z-score less than 0.24. In other words, that z-score represents the 54. So we're still realistically looking at the probability that an individual student got less than 54 on the exam. But we have to work with it in terms of the z-score. And that number 54 has a z-score of 0.24. And the way I got that was I went over here and I used the formula that we derived in class, and I found that the z-score was 0.24. It was actually a little bit bigger, 0.2439 I think. But I pulled it back because we're working with a table that does not take those z-scores out that far, and we're not going to extrapolate in the middle in the summer term, especially not in online office hours tonight. I would rather do that in class to talk about it in detail. So that's where we stand. So now let's look at a different example. It's not drastically different, but let's look at the probability that an individual student scores greater than 54 on the exam. Well, I know that the area underneath this curve equals 1. And I know that from negative infinity all the way to there is 0.59483. So I need to find what's left, because what's left is the greater than 54. So I could rewrite this, but I really don't need to. All I need to know is we're going to take 1 subtract 0.59483. 1 subtract 0.59483, because we know the properties of this curve. So I get 0.40517. So that's how much is this direction. Okay? And there we have it. So we've got 0.59483 on this side, 0.40517 on the other side. Now I could have rewritten that, but in this case I just didn't need to, because I'd already found the area and I know the properties of this symmetrical bell-shaped normal distribution. And I knew that the area underneath equals 1. Okay? Again, if you're in my class, let me know you're here. I always jot down who's here. So far this year, I think I'm 0 for 0. I don't think anybody's shown up in summer term. But I've had folks show up to class and say, hey, where do I get tutoring? And I keep reminding them that if you come here, you'll get tutoring from the same person that writes the tests and the quizzes and the homeworks and everything else. So if you need help, you can certainly go get tutoring from anybody. I'm okay with that. But right here is an easy way to do it. And I don't mind sitting here for anywhere from 30 minutes to an hour and a half if you have questions. Not a problem. And if you come from outside sources and you have any questions while I'm walking along, no problem at all. I'll answer them to the best of my ability. If you throw a physics question at me, I'll answer it logically. It's been a long time since I've looked at physics, a long time since I've looked at maybe Calc 3 or Advanced Calc, but I'm sure we could wind our way through it, and then I could come back with a follow-up video once I had some time to digest it. So not a problem. Okay, so let's look at a different problem, and let's look at one that we're just going to work straight with z-scores in this particular problem. So I'm going to look up here, and I'm going to, let's say that we've got a z-score of negative 2.7 right there, and I've got a z-score up here of 2.97. Okay? And I want to find the area in between those two. In other words, I want to find a probability that the z-score, that the z-score falls between negative 2.7 and 2.97. What's that probability? In other words, in just layman's terms, what is the area underneath the normal curve between a z-score of negative 2.7 and a z-score of 2.97? Okay, how do we find that? Well, there's a lot of different ways to skin this cat. The one I'm going to go down right this second, then I'll backtrack, show you a different way in just a moment. We find the area from here all the way to negative infinity. We find the area from here all the way to negative infinity. We subtract, and when we subtract it, the difference gives us the area between those two values. So we're going to find the probability that the z-score is less than negative 2.7, and we're going to find the probability that the z-score is less than 2.97. And we're going to do that using the table. So I'm going to flip over here on the table, negative 2.7. So let's find that one first. Negative 2.7 is right there. And it's negative 2.70. So it's that first column. So negative 2.7. So it's 0.00347. I'm going to write this in here even though you can't see it. We'll come back to it. 0.00347. Okay. Now I want to look at the probability that z is less than 2.97. I got to make sure I'm on the right side. I'm on the positive side now. So 7 is here. It's the third column over. So 2.97 is right there. 0.99851. Okay. I've used my table. I found my values. There's one value. There's that value. So in other words, the area from here all the way back to negative infinity, taking into account all the area underneath the curve to negative infinity, is 0.00347. The area from, let me just extend this up so I don't overlap too bad. The area from, I hate to do this, but from this z-score back, there's no area there in that white space, by the way. It's only the area from here back, but I didn't want to overlap what I had written there. So the area there is 0.99851. That's a 1. So if I take the longer one, if I take this one right there and subtract that off, then I'm left with this, which is the area underneath here. So I just take 0.99851, old school subtract 0.00347, 99851, not too hard, minus 0.00347. 99851, 0.00347. I forgot to put decimals in there. I got 99,504. 0.99851 subtract. It's going to be the same numerals. 0.00347. Yeah. 99504. 0.99. So 0.99504. So the area yeah, that makes sense. So the area there in between those two numbers, this particular z-score right here and this one, this area right here is 0.99504. So we've done it. So let's verify this. So let's look at, I've got, and I need to remember this, I've got negative 2.7 and 2.97. So let's switch to the calculator. Where's my calc? There it is. Let's switch to the TI-84 and let's walk through it with technology. Remember, I move a little bit quicker with going to technology in the summer term only because we have less weeks to work through some of this other stuff. So I try to get you well rounded before you walk out of here. I go second vars. That's not going to work to do it that way, no, is it? I go second vars because I need my distributions. So I scroll down, I'm in the normals, I scroll down to normal CDF, so we need that cumulative density function because we're taking into account every complete real number on that horizontal. So I hit enter. If you see up here, underneath my calculator, it says lower, upper, what is the mean of this curve, what is the standard deviation. We could work with all that. But all I need is two things. I need the lower z-score and the upper z-score. And in my class, I try to force the students to compute those z-scores. And you just put those z-scores in here. So our lower z-score in the second problem was negative 2.7. So I've got negative 2.7. That's the low point, the lowest point on the left-hand side. And then I put a comma, which is right above the 7. Excuse me, the upper point was 2.97. Close parentheses, hit enter. I get 99504. That sound familiar? Same thing. So we're good there. So if I scroll backwards, I said this the last time I streamed a couple of nights ago too. When you see me, if you ever see me just pause for a second is because I've got this streaming here, I've got this showing up here, I've got this showing up here, I've got the calculator. And sometimes I'm trying to use this to use the calculator when I need to use this. I'm trying to scroll here when I should be scrolling across the screen back to something else. So it's just me trying to get my bearings sometimes with all the stuff I've got up here. So now we're going back to this particular problem. And in this particular problem, we were dealing with less than 0.24. Okay, so if you're going less than 0.24, you're going all the way to negative infinity. Well, the calculator doesn't have a spot for negative infinity. If you go out past 5, really it's less than that, but if you go out past 5, you're good. So what I tell my class every single time is I say use negative 10 here and use 10 here. In other words, we are less than, so we're going all the way to negative infinity. You don't need negative infinity, you just need negative 10. And that will get you accurate enough for your assessments so that you're not off by a thousandth of a point or what have you. And I'll be sitting there scratching my head looking back at your work. It's easy. So we're going to go negative 10. So in this case, and I'll write it down here and then we'll go back to the calculator. We're going to go second vars, and then you scroll down to norm CDF, and I'm going to go from the lowest number, negative 10, comma, to the highest number, which in this case was 0.24 as a z-score, close a parenthesis, and we should get what we got here, which what we got here was 0.40517. So let's take a look and see if we do. So I go second vars, scroll down to CDF, cumulative density function, and I'm going to go, what did I say, it was negative 10, because we're going all the way back. That's my farthest left number, and then my farthest to the right is 0.24. Oh, I was about to say, it's 0.5948. So it's this one. I was circling the complement of it when we went greater than. Apologies for that. It's this, and that's exactly what we got on the calculator, 0.5948. 59483. Yeah, we're good. So we've used the calculator. We used just our sketch here, which was just an image that I brought in to overlay. And there you have it. So no questions. I see that there's somebody's in here, but I'm not sure if it's somebody from class or not. But by all means, if you have any questions, throw them out there from what you see on the screen. Now, if you walk into this at this point and you're not in the class, even if you're in the class, you're probably like, how did we get here? Wait a second. But we built this all the way from the ground up. So let's do one more example, and that's probably where I'll stop tonight unless somebody comes on from my class and has some questions. So let's do this. Isn't this well laid out? Look at this nice picture. I used GeoGebra, and there's a probability calculator in there, and you can lay out the normal curve. So this is, let me get out of that color, that's terrible. This is a standard normal. The standard normal has a mean of 0, standard deviation of 1. So if you ever have a normal curve that has a mean of 0, standard deviation of 1, that is a standard normal curve. Now, the data falling that way is probably a rare instance, but somebody has standardized the data curve 99.9% of the time. So that's what we've got here. So what I want to find is the area between these two z-scores, negative 0.7 and 1.2. Okay? So the way the probability looks computation, the way it's set up, is we want to find the probability that the z-score falls between negative 0.7 and 1.2. So we'll find the probability that it falls in there. So basically the probability equates to the area underneath the curve. So we're going to find the area underneath the curve, and the way we're going to do that is we are going to find the area from here all the way to negative infinity, and from here all the way to negative infinity. We're going to subtract, and that will give us the difference right here in the middle. So for the first one, doesn't matter which one you start with, but for the first one here, we're going to find the probability that z is less than negative 0.7. For the second one, we're going to find the probability that z is less than 1.2. Now, we talked about it last night in class before we took our exam. We talked about normal curves. But the reason we're going to the left, the reason that I am finding this and then this and finding the difference is because our table that we're going to be working with and our calculator is working to the left when we're looking for these less than values. So it's working to the left. So I'm just going to follow suit with that with what I'm working with. So the probability that z is less than negative 0.7. All right. I have to scroll up to my negatives. I've got negative 0.7. All these numbers have been pretty easy. So we're just at negative 0.70. So the area to the left of negative 0.70 or 0.7, however you want to look at it, is 24196. Okay. So I've got equals 0.24196. Okay. And the area to the left of 1.2, I have to go to the other side of the sheet. And again, 1.20, which brings you to that first column. This column is 0. This would be, that's 1.2, 1.21, 1.22, 1.23, all the way over to 1.29. So but we're just looking for 1.2, which leaves us right here, 88493. All right, so I've got my numbers. So I found the area to the left of here all the way to negative infinity, and it is 0.24196. And I found the area from here all the way to negative infinity, and it is 0.88493. What I'm going to do is I'm going to take all of this, which is the same as this, and I'm going to subtract it from all of that. In other words, it's going to, if I take all of this and subtract all of that, it leaves me with what's in between here. So I think I probably went around my elbow to get to what I was trying to say there, but 88493 subtract 0.24196, 64297. 0.64297. So about 64. The probability is there's about a 64% chance that the z-score will fall between those two values for whatever the context is. This is purely computational. So there you go. I've worked through just a few examples of normal distribution. As I told you in class, we had a test last night. I'll get those uploaded in the Moodle this weekend for you. Hand them back next week. Next week, we are going to have a quiz on the note sets on normal distribution, so be able to regurgitate your notes, formulas, the whole 9 yards. So study. My recommendation always is to study a little bit each night. I think folks have gone away from that over the years. Not saying that you guys are, but I just think students in general don't study every night like they should. Study every night, make note cards, whatever you have to do, and do well on that quiz this next Wednesday night, and we will finish up normal distributions. On the Moodle, I will load up the note set that I handed out in class last night. So you have that in case you lose the first one. I'll load up the standard normal table again, which is this. I've handed that out in class and loaded it to the Moodle already. I'll load it again, it's no problem. And I will load up your homework that will be due next week. So I'll put the homework set up there on the Moodle. Just print that out, or you can just look at it on the computer and write the problems out on a sheet of paper. That's fine too if you don't have a printer. It's no problem. So I'll put those up on the Moodle. I did not bring those with me last night. I just brought the test and the other handout. So that's all I've got for tonight. If anybody stopped by, it looks like somebody's on here. Thank you for stopping by. I appreciate that. If you're on YouTube or Twitch, just leave a like or follow or subscribe to the channel. It just makes me feel good at night. I am not a monetary streamer. I do this for my face-to-face classes. I do this for my statistics courses just to try to have an online office space that they can come in here and ask questions. If nobody shows, I usually have 2, 3, 4, maybe 5 problems at most that I will go through that kind of mirror what we're doing in class at the time. I'll put the video on the Moodle. It's always on my YouTube site, so my students can come back up there and reference it if they need to, and then ask questions in class or ask questions on the Moodle. Again, have a great Thursday night, and I appreciate everybody that has stopped by the stream. If you stop by, thanks. See if I can get this closed out. All right, have a good night.